This video is going to serve as a review of everything we've been doing in Chapter 3 with graphing lines, but our main focus that we want to take away from this is the idea of slope, the rate of change, the rise over the run, the steepness of a line. We really want to get down what a slope is going to look like, or what the line is going to look like when the slope is positive. It should be trending uphill. When the slope is negative, it should be going downhill. When our slope is undefined, we have a vertical line. And when our slope is 0, we have a horizontal flat line. So being able to know or recognize when a slope is positive or negative, undefined or 0 will give us a better idea of what the graph should look like, and it'll let us know if we're graphing correctly or not. So our first review is going to deal with positive slopes. We have a line in slope-intercept form. Remember, the slope is located out in front of the x. Our y-intercept is our constant, which is where we're going to cross the y-axis at. So my slope is 2. I am going to rewrite that as 2 over 1. So I know exactly how many spaces to rise and how many spaces to run. My y-intercept is -7, making sure I don't forget the negative out in front. So I begin at my constant of -7, which is where I cross the y-axis at. From there, I use my movement. So I'm going to rise 2 spaces, run 1, rise 2, run 1 to the right, rise 2, run 1 to the right. This is the same as going down 2 spaces, 1 to the left, because 2 negative movements still create a positive slope. In class, we have been doing a bike check. So if I create my bike, it would be going in the uphill direction. So I would have to be riding up a hill. So I know this is a positive slope. Looking at this as a table, so what coordinates lie on the graph? I have the coordinates 0, -7, which is my y-intercept, 1, -5, 2, -3, and 3, -1. I simply just took the coordinates that I plotted. This is a function because no x values repeat. They each have a special output. And I know it's linear because I graphed a line, but I can also check. I'm going up by 1, up by 1, up by 1 for my increase in x. My y is increasing by 2, increasing by 2, increasing by 2. It follows a constant rate of change. Therefore, it is a line. If I wanted to rewrite the slope, I am writing my change of y over change of x, which is 2 over 1, or 2. That checks back to my slope of 2. We are going to review negative slopes by looking at a line in standard form. All right, so in standard form, if I want to graph my line, I'm going to change it into something we know. I'm going to change it into slope-intercept form, which means I need to isolate my variable of y. So my first step is to add 5x to both sides. So I have -2y is equal to 5x minus 14. And then every term is divided by -2. So y is equal to 5 and 2, or 2 is not divisible. 5 is not divisible by 2. So therefore, I'm going to leave that as a fraction, as -5 over 2. 2 does go into 14, though, so I'm going to add 7. Now I've changed this into slope-intercept form, so I'm going to write down my slope is -5/2. My y-intercept is +7. This time I'm going to begin at 7. And then my movement is down 5 spaces, 1, 2, 3, 4, 5, to the right 2. Down 5, right 2. Down 5, right 2. Once again, we can do our bike test. If I draw my bike, now when it travels, it is going downhill, so I know I've created a negative slope. If I write down my coordinates, this time I have 0, 7, 2, 2, 4, negative 3, and 6, negative 8. This is a function. No x values repeat. It is linear because it has a constant rate of change. Every single time I look between my x's, I have an addition of 2. With my y's, I am subtracting 5. So my change in y over change of x, or my slope, is negative 5 over 2, which once again matches my slope. A slope of 0 is going to be in the form y equals negative 4x. I could rewrite this in terms of slope-intercept form if I add in a 0x, because remember, 0 times anything is 0, and 0 minus 4 is 4, so it would give us back to our original equation. However, sometimes this is easier visually. So I'm going to recognize that my slope is 0. I am going to write that over 1, so I know how many spaces to rise and run. My y-intercept is negative 4. So I'm going to begin at negative 4. My movement is rise 0, run 1. Rise 0, run 1. Rise 0, run 1. That's why I get a horizontal flat line. My coordinates are 0, negative 4, 1, negative 4, 2, negative 4, 3, negative 4. It's important to recognize that the y value is always negative 4. That's what gives us our horizontal line. This is a function. None of my x values repeat. Is it linear? Does it have a constant rate of change? So my x values are adding 1 every single time. There is no change to my y value, so that's like adding 0. So my change in y over change of x is 0 over 1, which is 0. So I have a slope of 0. Our last slope is undefined. This looks a bit different than all other lines that we have worked with, because instead of saying y equals mx plus b, whatever the line may be, we have x equals 5. That means we're looking at an x-intercept of 5, and an undefined slope is a vertical line. So if I write down a few points, I have 5, 0, 5, 1, 5, 2, 5, 3. It's important to note that every single x value is 5, and our equation is x equals 5. This is not a function. It is not a function because x repeats and has multiple outputs. If we look at it as a line trying to find a constant rate of change, the x values never increase. So there is no change in our x. Our y values are going up by 1. So if I write this as a change in y over change of x, my change in y is 1. My change in x is 0. I am not allowed to divide by 0. Therefore, my slope is undefined.